Thanks for coming, and thanks to the organizers for giving me the opportunity to give this talk. So, yeah, digital, is this working? No, it's not working. Never mind. Just use this thing. Right.
Another one for you, if you like to. Oh, is this
well, it's plugged, yeah.
I thought you need a laser pointer.
No, just need to...
Sorry.
Seems to be plugged though. Sorry about that. Right.
Next year is a track for fault tolerance.
Yeah. Okay. And the arrows are not working. La -la -la. Right. Ah. Yeah, so you probably, well, I've been to, I think it's my third time here in Berlin. It's nice to be back. So some of you might have seen me in the past talking about other things. If not, so I run Digital Pebble, which is a small consultancy based in Bristol in the UK, doing pretty much anything with text on a large scale. So going from web crawling, which is what I'll be talking about today, to natural language processing, building search systems, or machine learning. What we do at Digital Pebble is mostly using open source, and especially Apache stuff. So I use or contribute, or I'm a committer on quite a few projects. Apache Nutch, which is a web crawler, which I'll mention in my slides, but other Apache things like Tika and so on. Who knows about Apache Nutch? Oh, okay, well, surprising. So who's been to the talk this morning about Storm? Yeah, cool, excellent, great. Now, the project that I want to tell you about today is called Storm Crawler, which is a very original name, and it basically does what it says on the tin. It's about building web crawlers on Apache Storm. So it's a collection of resources. It's an SDK. The code lives on GitHub. It's under Apache license, and all the artifacts are on Maven Central. So you can pull the stuff, the jars in the usual ways. It's a relatively young project, I mean, compared to Nutch. It's been around for probably a year and a half. But it's very active. It's growing fast. It went from me being the only committer to having 3 more committers, and yeah. So we've just released a new version last week, literally. So what I wanted to achieve with the Storm Crawler was to have something that can scale. Well, it doesn't have to. I mean, we don't all need to do billions of pages, but something that can potentially scale if needed, something that can do low latency, also be able to use, well, easy to use and extend. We'll have a comparison with Nutch later. and also, of course, all the nice features that we want to have, like processing sitemaps, or be able to do web scraping, which is a lot of people need to do, be able to do that in a nice way. And also your things like, yeah, sitemap, politeness, all these things that we want with a web crawler. What it's not, being an SDK, is a well-packaged application. So there's a minimum amount of code and configuration that you need to do. There's also no like global processing of the pages, like doing a page rank, like Nutch can do. That's because it's that's backend specific. It depends on where you store your data. It would be done typically with a MapReduce or a Spark job. So that's a bit outside the scope of the Storm Crawler. And yeah, it doesn't have any fancy UIs or dashboards. You'd use the Storm UI, but also you can plug the Storm metrics to various backends. So in a way, it's quite flexible. You can integrate it in whatever you're planning to do with your project. So yeah, I mentioned Nutch. Nutch is, as you know, a very popular piece of software, not only because it gave birth to Hadoop, just a minor detail, but also because it's one of the few projects that you can use to build large-scale crawlers. And I happen to know it pretty well. I've been a committer on Nutch for quite a while now. So yeah, people often ask me, why have you done the Storm crawler? You already have Nutch. So one of the reasons was that, yeah, Nutch is batch-driven. So imagine you do, it works by steps. You do a first step of generation. So you select all the URLs that you want to fetch. Then you do the actual fetching of these URLs. Then you parse them to get the outlinks and also the actual content of the pages. And the next step is to update the what's called the crawlDB, which is a sort of database about the URLs. And then you can index, of course, the pages. So that's 5 or 6 different steps. They all run sequentially, which means that when you're fetching, you're not parsing. When you're parsing or updating or generating, you're not fetching. So you're not, in terms of the use of the resources, it's not really optimal. You should be always fetching, always parsing, always updating. So you're optimizing your network, your CPU, your disk access, everything. The main thing is that with all these batch jobs, you have very little control as to when URLs are actually fetched, which means that if you need to handle low latency, imagine you need to scrape a site that uses sessions. Sessions are often time limited. With Nutch, you have to do all sorts of contortions to be able to do that. It's not a very natural fit. With the Storm crawler, yeah, it's a much better fit. What else? Yeah, but the Storm crawler as well is a lot more flexible to use. Very often, you just reuse the existing classes in the SDK, and I've had quite a few users who literally had like 3 Java classes, a couple of configuration files, and bang, they could build a scalable crawler just with that. So it's quite elegant in a way. But it's not as ready to use as Nutch, of course. Nutch, you install it, and hopefully, luckily, you're able to use it, and that's it. You can play with the configuration. Again, the Storm crawler is an SDK, so you need to build a bit of code. But some of the code and a lot of the concepts were borrowed from Nutch. So Storm crawler probably wouldn't have existed without it. But the nice thing is that I managed to contribute some of the stuff back to Nutch, so it works both ways. So there was a talk this morning about Storm, which was really good, so I can go very quickly over my Storm slides. Storm is a distributed real-time computation system, top-level project at Apache, so a mix of Clojure and Java, and it's used for all sorts of things, real-time analytics, continuous computation, and so on. So it's a very popular piece of software. The concept, and that's what I really like with Storm, is that it's nice and easy to understand, but it's quite powerful at the same time. So as we've seen this morning, you have spouts that generate tuples onto streams, and then you have bolts operating on these tuples and modifying them or creating new ones. So basically, yeah, spouts, bolts, streams. So what do we have in the toolbox? What does Storm crawler provide as a project? So we've separated the code into 2 modules. One, core one with the stuff you would necessarily definitely use with the Storm crawler, and the other one we put all the stuff which is related to external projects like Elasticsearch or Tika, just to keep things separated and simple. There are also quite a few, at least one. Repository of external contributions, so people have their own GitHub repository. Wow, already halfway, I have to speed up. So, next one. So the main bolt you need is obviously the one that does the fetching. So it's, the ones of you who are familiar with Nutch will recognize some of the concepts. So it's, multi-threaded bolt that has internally multiple threads to do the fetching, and puts all the incoming tuples into queues. So that's a way of handling the politeness that you can have control as to the rate at which you send queries to a server. There's also a simpler version of the bolt, but that other one requires to handle the politeness at the spout level. Yeah, and there's the protocols are protocol neutral in the sense that the protocols are a separate component. It's not part of the fetcher itself, so you can reuse the default one based on the Apache HTTP client, but you could also write a custom one if you needed to. The second most important component is the one that does the parsing of the pages. So this one is it's based on JSOUP, and so it handles only HTML. But if you need other formats, remember I mentioned earlier there is one based on Tika, which is in the external part of the code. And so this parsable extracts the text from the documents and also the outlinks and various metadata from the web page. But it does two things. It calls the URL filters, which are pluggable sort of classes, which allow you to normalize or filter outlinks. So that's basically how you control the expansion of your crawl. And also parse filters, which are, again, pluggable classes, which is where you can do, for instance, extract metadata with XPath or do whatever you want to do in terms of scraping. So these are the most commonly used things, and that's all happens within the JSOUP parser. So as I said, yeah, parse filter is just basically a very simple interface. It's configured with a JSON file, and it comes with a few default implementations. So there's this one, the XPath filter, where in the JSON file, you just give it a number of XPath expressions, and then it will store all the matches into the metadata for the page. So it's a nice and easy way of doing scraping, really. Same with the URL filters. So that's how you control the how your crawl expands. And yeah, there's a number of filters available. I won't go into the details because I'm running out of time. So a very basic topology would look like this. You'd have some spout pulling URLs from, say, a queue or any form of, well, some form of external storage. It has to come from somewhere. And then, yeah, some partitioning to make sure that the URLs are sent to a single, so URLs from a single domain would go to the same instance of a fetcher. Again, you can have just more than one instance, obviously, of all these bolts. Yeah, the parsing, and then you do something with it. You would index it with Solr or ElasticSearch or store it in a database. So that's a very, very, very basic topology. From the point of view of the tuples, this is the sort of fields and tuples pass between these various components. Yeah, the slides will be online, so it'll be easier to find them later. So, as I said, the spout could be something as simple as RabbitMQ or AWS SQS, and the indexer can be ElasticSearch or Solr. All the components in gray are the ones provided by Stormcrawler by default. So and some of the ones for the indexing could also come from Stormcrawler. So it's very likely you'll need to basically just provide a spout implementation, the topology class itself, and that's it. Bob's your uncle. Great. What about recursive crawls? So when we have, that works fine when you have just a set list of URLs and everything. But when we have recursive crawls, we need something a little bit more, or failure, you need something a little bit more complex. So that's what a proper crawl would look like. You have, you start from seeds and then you follow out links. So some links can take you back to the URLs you've already visited. Some of the links you don't want to go, the ones with the little stop sign, that's what you'll need the URL filters for. So one thing that the Stormcrawler does for handling cases like this is that we use, I mentioned the streams before, and in Storm you can have, there's a default stream, but you can have as many different streams and give them a name as you want. So the strategy we use is to have one which is called status. So the components like the fetcher or parser will emit the normal, well, the output for a given document on the standard stream, but also generate other tuples on the status stream to send that to another bolt that you'd have, which is, I called it status updater here, and that bolt will be in charge of basically send that to some sort of storage where a DB or Elasticsearch or whatever you want, where you'd have, the URLs would be stored. You'd basically have one entry per URL. I mean, if you were sending that back to queues, you don't want to add a URL to the queue every time you find it as an outlink. So a bit more complex, but yeah, with these two streams, that's how you can deal with it. So yeah, that's the status that a tuple can have. So it's been either discovered or already fetched or have a redirection or an error. If you think of, you have a .gpdf document, and Nick mentioned some of the stuff you can come across with Tika, for instance. So yeah, you can get an error. So the status updater, its function is to write to the storage. And what you can do is you can extend, there's an abstract class you can reuse and makes your life easier to write such components. Yeah, I mentioned the core part of the project. In the external parts, there are quite a few things for Elasticsearch. I mentioned them now that we've seen the status stream and so on. So yeah, there's obviously an indexer bolt that takes documents indexes them. But there's also a status updater bolt and an Elasticsearch spout bolt. So these are used for doing recursive crawls. And there's also one thing I really like is the metrics consumer. So Storm can generate metrics, has a nice API for that. And this class allows you to send the metrics to Elasticsearch. So then you can use Kibana, for instance, to display the metrics of your crawler. So you can see the pages per second and so on. So I've already mentioned some of it. So how to use it? Well, the thing you need to do is maybe at least write a topology class, so where you define the bolts and how they are connected to each other. Or you can take the example one in the code and hack it. You probably need to write a few resource files for the URL filters and pass filters, package the stuff with Maven or any other tool you like, and then yeah, you call Storm on it, and bang, you have a crawler that can scale, and with minimal amount of code to write and minimal configuration. So that's what a topology class would look like, and I'm not sure you can see very well, but yeah, we can see all the different bolts and how they are connected, and how they are grouped as well, which is quite important for politeness and also for performance. That's the Storm UI. So if you launch Storm in distributed mode, you'd see something like this. You can see how your bolts are performing and the latency of each bolt. So you can find bottlenecks. It's a pretty good tool and a good way of monitoring your crawler. So I'll go quickly through that. It's been used, I've used it for quite a few clients and quite a few committers. Well, people who are now committers have used it for their projects. So we've had cases from the very simple ones where you have existing list of URLs. We wanted to fetch and parse them. So that's pretty straightforward. So that was just RabbitMQ for the spouts and then Elastic for the indexing. To pretty much every possible use case in between, to more complex crawls with a full recursive thing, and that used DynamoDB, and that's running on production on EC2. What's next? So as I said, just released 0.5. There's been some work done on the documentation, but who likes writing documentation? So there'll definitely be more work on that. Also, as I said, that's an SDK. What we'll probably try and do and have like an example an example project showing the full recursive crawler thing. So probably based on the existing components we have for Elasticsearch, and that would be a good example to show how to use Storm crawler. And yeah, probably add a few more parse and URL filters and so on. One thing that will certainly happen is to have a Selenium-based protocol implementation so that we can deal with these pesky Ajax pages. That's it, few resources. So there's a very good book published by Manning on Storm, which really helped me understand it better. But yeah, otherwise, yeah, the project, as I said, the project's on GitHub, and there's links for Storm and Nutch as well. That's it. Do you have any questions?
Thanks. Let's take the speaker first.
Thanks.